Hello, today I'll be going over 6.4, which is use inverse functions. So an inverse function is when you switch the input and output, which basically means you switch x and y in the equation. They are inverse functions if both the original and inverse functions are functions. And if you plug in the inverse and you get so if the inverse is g of x in this equation, then f of g of x will equal x, and g of f of x will equal x. And for the horizontal line test, so it's similar to the vertical line test. This is to test if the equation is a function. So if in pink these are the graphs of the inverse, then you can use a horizontal line test to see if it's a function. So if we draw a horizontal line and it crosses the graph at more than one point, then that means it is not a function. So here it crosses it twice, so it's not a function. And if we drew one here, it would only cross it once, so this one will be a function. Okay, so for the first two examples, we want to find the equation for the inverse function. So that's when we switch x and y. So for all the y's, I'm going to replace it with an x, and all the x's, I'm going to replace with the y. And then I want to solve for y. So for this problem, I will want to subtract 2 on both sides. So I get x minus 2 equals negative 2/3 y. And then you can either multiply both sides by negative 2/3 or multiply by negative 3 and then divide by 2. I'm just going to multiply by negative, oops, did I say 2/3? Multiply by negative 3/2. So we want the reciprocal of this, so that equals 1. So we're going to multiply by negative 3/2 on both sides, and then we'll get y equals negative 3/2x plus 3. So this here is the inverse function. Okay, number 2, f of x again means y, so if it helps, I'll write this. Y equals 3/4 x to the 5th plus 5. So we're going to replace all the y's with x and all the x's with y's. So x equals 3/4 y to the 5th plus 5. And we want to solve for y, so first we have to subtract 5 on both sides. We'll get 3/4 y to the 5th equals x minus 5. And then to get rid of the fraction, I'm going to multiply by 4/3 on both sides. So we get y to the 5th equals 4 times x minus 5/3. And then to solve, we would square root both sides. Or not square root, sorry, fifth root both sides. Because the 5 on the outside here will cancel out this 5 here. So that'll be y equals fifth root of, I'm just going to distribute, so that's 4x minus 20/3. And this here is the inverse. Okay, number 3 and 4, we want to verify that f and g are inverse functions. So what we want to do is prove that f of g of x equals x and g of f of x also equals x. So for this one on the left, that just means we're going to replace all the x's in f with g of x. So that'll be 2 times 1/2 x minus 3/2 plus 3. So what I did there was replace this x with all of this here. Okay, so we'll get x minus 3 plus 3, and that equals x. Then for g of f of x, we want to replace the x in g of x with the equation for f of x. So I'm replacing that x with 2x plus 3. So that'll be 1/2 2x plus 3 minus 3 over 2. Then we're going to distribute the 1/2 and we'll get x plus 3 over 2 minus 3 over 2, and we get x. So that means these are inverse functions. Okay, number 4, we're going to do the same thing. So we want to find, or we want to make sure that f of g of x equals x and g of f of x equals x. So I'm replacing all of the x's in f of x with 5x plus 5. So that's 1/5 5x plus 5 minus 1. That'll be x plus 1 minus 1, which is x. So this one is correct. And then for the next one, we want to replace the x in g of x with 5x minus 1. So that would be 5 times 1/5 x minus 1 plus 5, and then distribute the 5, so we get x minus 5 plus 5, which is x. Okay, next we want to find the inverse of the power function. We have f of x equals negative 10x to the 6th, and x is less than or equal to 0. So if it helps, I'll replace this with the y first. And to find the inverse, we're going to switch the x's and y's. So x equals negative 10y to the 6th, and then we want to solve for x. So we have to divide by negative, or sorry, we want to solve for y. So we want to divide by negative 10. So y to the 6th equals negative x over 10, and then we're going to take the 6th root on both sides. So y equals 6th root of negative x over 10. And it says that x is less than or equal to 0, which means x equals 0 or it's negative, which would make the inside the radical positive or 0. So that's why it's not no solution, even though there's a negative sign. Hopefully that makes sense. Okay, number 6, I'm going to replace the g of x with y. And then to find the inverse, we're going to switch them. So x equals 32y to the 5th. To solve for y, we're going to divide by 32. So y to the 5th equals x over 32. And then we're going to 5th root both sides. So we get y equals the 5th root of x over 32. And for this problem, we can actually simplify more because we can split this up into 5th root of x over 5th root of 32. And the 5th root of 32 is 2. So y would equal the 5th root of x over 2. Okay, and in the last section, we want to graph the function and use the graph to determine whether the inverse is a function. So we have f of x equals negative x minus 5. So this is a line. I'm going to start at negative 5 on my graph, go down 1, right 1, and then create a line. Okay, so this is my graph, and if I draw a horizontal line, it should only hit the graph once. So here's just an example. No matter who I draw this horizontal line, I'll only hit it once. So the inverse is a function. Okay, number 6, we have f of x equals cube root of x, or sorry, not cube root, x cubed minus 2. So I'm just going to make a table on the side and plug in some points. Let's plug in negative 1, 0, 1, and 2. If I plug in negative 1, negative 1 cubed is negative 1, so we get negative 3. If I plug in 0, I get negative 2. If I plug in 1, 1 cubed is 1, minus 2 is negative 1. And then if I plug in 2, 2 cubed is 8, 8 minus 2 is 6. And you can plug in more points if you need to. So negative 1, we have negative 3, 0 is at negative 2, 1 is at negative 1, and 2 is at 6. So here. And if you remember the shape, it's going to look something like this. Okay, so we have the graph, and now we want to draw a horizontal line. And we should be able to draw anywhere, and it won't cross the graph at more than one point. So I drew it there, and it won't cross at more than one point, but no matter where I draw it on the graph, it won't cross at more than one point. So the inverse is a function.